Now suppose we have a group of 11 persons. The first question is how many ways to choose 3 members from this group of 11 to work as a team. That's exactly what this combination means, right? So how many ways to choose 3 out of 11? Well, hopefully you can sense that the order really doesn't matter here. We just want to form a group. So ABC being chosen is the same as ACB being chosen, is the same as BCA being chosen. So that's a typical combination. So therefore we just use this 11 choose 3, N is 11, R is 3. And earlier we did this 11 choose 3, I believe, right there, which is right there, which is 165 in my last video. So let's skip the calculation, just say 165. Now, suppose 4 members of the group insist on working together. They cannot be separated, basically. Any team must either contain all 4 or none. And how many 6-person teams can be formed? You're always welcome to pause the video if you want to take a moment to think about it. So we have 2 cases. Case number 1, all these 4 people are in the team, right? Case number 2, all these 4 people are not in the team. So it's either they're in the team or none of them are in the team. So I'm gonna say, suppose case 1, all 4 are in the team. And another possibility is none are in the team. Well, it's either this or that. I hope that you're sensitive on the or. When we say or, that means addition rule. So basically we have this scenario or this scenario, right? So or this scenario. So we need to add. We need to add. When you hear or, that means we need to use addition to add these 2 possible outcomes. Now, always, let's consider the first scenario. All 4 are in the team. Step 1, keep in mind we are looking at a 6-person team, right? So step 1, choose all 4 are in the team, right? How many ways to do that? Only one way, because you want to choose these 4 to include that in the team. So 4 people, you choose 4 of them. So this is actually just equal to 1. 4 choose 4 is equal to 1. Step 2, we have 2 remaining need to be chosen to form this 6-person team. And the last 2 persons have to be coming from the remaining, after 4 chosen, 7 people left, right? We need to choose 2 persons from the rest of the 7 persons. So we're going to say choose 2 persons from the rest of the group, which means 7 choose 2, right? So 7 choose 2, which is well, I'll leave you the algebra. So basically I'll just keep 7 choose 2. So how many ways can these 4 people are in the team? Because this is a step-by-step process, we are going to use multiplication rule. So which means 1 times 7 choose 2, which is 7 choose 2. So the total number of ways is going to be 7 choose 2, right? Basically 1 times 7 choose 2. Basically essentially 4 choose 4 times 7 choose 2. Now let's take a look at the second scenario. None are in the team. None are in the team. So you can, basically that means you just choose all 6 people from the the rest of the group, not containing these 4 people, rest of the group. Which means 7 choose 6, right? 7 choose 6 is just 7, that's easy. So now, therefore my final answer will be 4 choose 4, which is just 1. So 4 choose 4 times 7 choose 2 plus 7 choose 6, okay? And this is just B1. 7 choose 2 is 7 times 6 divided by 2. And plus, oops, I'm sorry. That actually is going to be 7 factorial, and then 7 minus 2, which is 5 factorial, and then 2 factorial, plus 7 choose 6 is 7 factorial, 6 factorial, and 1 factorial. And by the way, this will be 7 times 6 divided by 2. Give a little explanation. And then plus, basic just 7. So this is 42 divided by 2, which is 21, plus 7. So total 28. 28 possible ways to form a 6-person team. Okay. Now, next scenario. Suppose 2 members of the group refuse to work together on a team. How many 6-people teams can be formed? Again, pause the video if needed. So suppose 2 members, let's make it generic. Say A and B, they refuse to work together. So therefore, to form a 6-people team, then when A is on the team, so A on the team, then B cannot be on the team, right? B, so B on the team, but not B, not B. So this is possibility number 1. And similarly, you can say, similarly, B on the team, but not A, right? But not A. Or both are not on the team. Both not on the team. Okay, only these 3 possibilities. And again, it's either this or that or that. Then you have to add all these together, all these results together. So A is on the team but not B. That means step 1, choose A on the team. Only one person, that particular one, A, choose A. Okay, 1 choose 1. Sometimes this you don't have to write this, but now I just want to emphasize the step-by-step process here. And then so because we have 11 people, therefore A is on the team, so we are left with 10 people. And B cannot be chosen, therefore we are left with 9 people to choose from, right? So the rest of the 5 must be chosen from 9 that's available. It's not 10 because we cannot choose B, so it has to be 9. Okay, so this is, and similarly, the second one is B, choose B, so only one B and we choose the B. And then A cannot be chosen, so we are left with 9 people, so 9 choose 5. They should be, like we can basically, this scenario and this scenario, they should be the same result. And then not both. Not both means we cannot choose A and we cannot choose B. We have only 9 people left out of 11. Then we choose 6. So 9 choose 6. Okay. So therefore, that's all the possibilities. And then to answer this question, we are going to just say 9 choose 5 plus 9 choose 5 plus 9 choose 6. And then I'll leave you the opportunity to complete this algebra, and the expected answer is, the target answer is, according to my 336, according to my algebra, right? So that's your target answer. Let's do a few more, then we are going to talk about another classical problem. Oftentimes you will see those phrases like at least n. So at least n means greater than or equal to n, right? N or more, right? At most n means less than or equal to n. So hopefully you're able to correctly interpret those terms. Now let's take a look at the next type of problem, which is one step further compared to previous problem. Here we not just say how many person, we actually have two categories of person. One is male, the other one is female. And let's say suppose we have 9 male students and 5 female students in the class. And then how many committees of 3 students can be chosen? That will contain 2 female and 1 male. Okay, 2 female and 1 male. So now, without really writing that down, let's just talk about the steps. So the step number 1, I want to choose 2 female, and 2 female is going to be chosen from 5 female, right? So step 1 is to choose 2 female from 5 female students. That's still step 1. Step 2, we'll have to choose 1 male from 9 male students. So because we say step 2, that means we need to multiply. When you have step-by-step process, according to the multiplication rule, you just multiply. So 9 choose 1. Okay, so that's the how we do the first one. And this is equal to 5 times 4 divided by 2 times 9. Okay, and this is actually 90. It's 90. Now at least one female. Let's talk about at least. That means 1 or more, right? So therefore it can be 1 male, or 2 males, or 3 males. And that's all because we have a committee of 3 students. You cannot have more than 3. So those are the all possibility. And one male, that means 9 choose 1, right? So step 1, choose 1 male from the 9 students. If you just stop here, that will be wrong because you still need to choose female students to form committee. That means step 2, you have to choose 2 female from the 5 available to form this committee. The or means you have to add. Now 2 males, probably you can just finish up the rest now. So 2 male means you have to choose 2 male from the 9 males available. And then now female, you just need 1, right? So 1 will be chosen from the 5 female students. And or again, a plus. So 3 males, that means 9 choose 3. And how many females you're going to choose? That's already 3. So you're going to choose 5, 0 from 5 female. And this will be always 1. So oftentimes you don't really need to write that down. Okay. So therefore this is going to be, and you just complete the algebra. So this one we already did it up here, which is 90. The second one will be 9 times 8 divided by 2. And then times 5, that's 9 choose 2 times 5. And the last one is plus 9 times 8 times 7 divided by 3 times 2 times 1. Okay, and after the algebra, I think this is equal to 354. You can check that for me. Now, how about next one is more male than female in this committee? That means either 2 males, 1 female, or 3 males, right? Those are two possibilities, that more male than female. And that means 2 males, that means 9 choose 2. 1 female times 5 choose 1, plus 9 choose 3. Okay, and we did the algebra above, so you can quickly finish this one. And the next one is how many committees of 3 students are possible. Now let's suppose in this group we have a Jacob and we have a Tony. Both are boys. Okay, both are boys. How many committees of 3 students are possible if Jacob will serve if and only if Tony does. That means they either they serve at the same time or they do not serve at the same time, right? That's what it means. So basically it's either Jacob and Tony both serve, or both not serve, okay? Both not serve. So two possibilities. And when they both serve, that means two members are already determined. Like these two of the members, these two have to be chosen. So choose two. And for the very last one, because we have a total of 14 students, twos are chosen already, and then how many we have left? So it will be 12, total 14, right? Total 14. So two are already chosen, so we are left with 12 students to choose from, and we just need one more, so 12 choose one. Or means add. Let's move this closer. Both not served, that means two cannot be chosen, and then the rest of 14 will choose 3. So this is how we handle the part D. Now suppose Kyle and Aaron do not get along and will refuse to work together. How many committees of 3 are possible? Okay, so in this case, again, very similar to one of the problem we did earlier. When Kyle serves, Aaron doesn't, okay, and no Aaron, okay, no Aaron. We have Kyle but no Aaron, okay, no Aaron. So this scenario number 1. Or we have Aaron but no Kyle. And then or we have none of them. So therefore, when Kyle serves, no Aaron, that means we have to choose Kyle, 1 choose 1. And we have total of 14 students. Kyle is chosen, we are left with 13. Aaron cannot be chosen, so we are left with 12 to choose from. So we are going to choose 2 from the 12 remaining. And this will be the same, Aaron but no Kyle, 12 choose 2, right? And none of them, that means we are going to choose 3 out of the 12 remaining. So therefore the answer is just adding these 3 together. So 12 choose 2 plus 12 choose 2 plus 12 choose 3. Okay, and let's finish this video by completing the last one, and then we'll make a separate video for this classical problem. Now, for the last problem, we want to divide 14 students into groups of size 5, 5, 4. So how many ways can we do that? Okay, and this is a very good problem. I think this technique is very useful. So the first step we do is we can form a size of 5. So we choose 14 students, and we choose from 14 students 5 students, right? So to form the first group. Now after the first group is formed, the group of size 5 is formed, then we are gonna choose another group of size 5 from the rest of the students available. Because 5 is already chosen, we are left with 9 available for us to choose, which is, so 9 choose 5. And the last, for the rest of the 4 students, they automatically form a group, right? So you can stop here, or you can just say we have remaining 4 students, and we are going to choose 4 of them to form the last group. Now I do want to carry out this algebra now, just to look at the pattern. So how do we find 14 choose 5? It's 14 factorial, 9 factorial, which is 14 minus 5, which is 9 factorial, divided by 5 factorial, times, now let's compute the 9 choose 5. So it will be 9 factorial divided by 9 minus 5, which is 4 factorial, and then times 5 factorial, right? And the 4 factorial means 4 factorial divided by 4 minus 4, which is 0 factorial. and then times 4 factorial. Now you see a lot of cancellation can be done. So 9 factorial cancel out 9 factorial. 4 factorial cancel out 4 factorial. And this 0 factorial is just equal to 1. Now let's write this out. So you have 14 factorial on top, 5 factorial on the bottom, times 5 factorial on the bottom, times 4 factorial on the bottom. Now the reason I want to write this form, I hope that you can do a little observation. Can you see the pattern? Where's this 5 factorial from? It's from here. Where is the next 5 factorial from? It's from here. And last 4 factorial is actually from here, okay? So this is actually the one of the formula that we will be introducing at the end of this section. So if I say let's divide the 14 students into 3 groups of size, say 2, 3, and 9. Groups of size 2, 3, and 9. How would you find that? You can quickly find that by doing this. 14 factorial divided by 2 factorial, 3 factorial, and 9 factorial. So that's the shortcut. That's what we try to derive. All right. So we'll finish this video. We'll end it here, and we'll talk about poker hand problem in the next video.